Hey guys, what's up? Today we are gonna learn about optical fiber and its type. This is my project for engineering physics in VIT Vellore. My name is Arnav Bhargava and my registration number is 20BCE0893. Moving on to the topic, first let us know what does optical fiber is. Optical fiber is an optical transmission device which works on the principle of total internal reflection. Its principle is when a light signal is directed at one end of the fiber at a suitable angle, it undergoes repeated total internal reflection along the length of fiber and finally comes out at the other end. Then moving to the constituents of optical fiber, it consists of core, cladding, buffer, and jacket. Core is a glass or plastic with a higher index of refraction than the cladding. Its function is to carry the signal. Cladding. Cladding is a glass or plastic with a lower index of refraction than the core. Then coming to buffer, it protects the fiber from damage and moisture. Jacket. Jacket holds one or more fibers in a cable. The radius is also given in this figure. The notes will be provided in the description link. You can download it from there. Moving to the advantages, optical fiber have greater bandwidth than copper transmission lines. Optical fiber lines have much less signal loss than the copper transmission line, which is very beneficial to us. Fiber is lighter and smaller in diameter and is very less expensive than copper line. Since the signal is not electric, so it does not interfere with the electrical signal. It is not possible to tap an optical line the way a copper line can be. Fiber systems are very useful in hazardous environments where electrical signals might cause sparks. Then moving to other advantages, its potential low cost. The glass which generally provides optical fiber transmission medium is made from sand, wh- which is easily available. It has enormous bandwidth. The optical carries frequency in the range of 10 to the power 13 to 10 to the power 16 Hz. In metallic cable system, bandwidth is 500 to 700 megahertz, the amount of data that can be transmitted in a fixed amount of time. Signal security also. Optical fibers provides a high degree of signal security. Then moving on to its specification, it contains of various losses such as attenuation, which is basically loss of signal and is measured in decibels. Dispersion is the blurring of a signal which affects bandwidth. Bandwidth is the number of bits per second that can be sent through the data link. Numerical aperture is the measure the largest angle of light that can be accepted into the core. Acceptance angle is the angle which is the maximum angle in which the light can go into the cladding. Then coming to its types, basically it's of two types, which is single mode step index fiber and multi-mode fiber. And multi-mode fiber consists of multi-mode step index fibers and multi-mode graded index fibers. Moving on to their description. Now, moving on to their types, multimode step index, it's basically when the refractive index of the core is uniform throughout its medium. Basically, if we try to plot a graph of its refractive index uh, of the core, it's a straight line, whereas the refractive index of the cladding is as usual low. Multimode graded index, it basically the difference in multimode step index and multimode graded index, it's the refractive index of the core changes in multimode graded, whereas it does not change in multimode step index. Moving on to the single mode step index, it's basically a thin tube like, and the it's same as multimode step index, but the difference between single mode step index and multimode step index is basically it can accept more than one signals. Moving on to their description, single mode step index fiber. It, it has a core diameter of 8 to 9 microns and it only allows one light path or mode. It has a lower signal loss and a higher information capacity or bandwidth than a multi-mode fiber. The graph of the refractive index is also given here. Moving on to multimode step index fiber, multimode fiber has a core diameter of 50 to 100 microns, which allows various several light paths or around 100, which causes modal dispersion, which is some modes take longer to pass through the fiber than others because they travel a longer distance. It's a good point from the exam point of view. Moving on to the multimode graded index fiber, the index of refraction gradually changes across the core. In this, the modes that travel further also move faster. This reduces modal dispersion, so the bandwidth is greatly increased. The graph of the refractive index of the core and cladding is seen here. Now, the difference between the step index and graded index is basically step index multimode was developed first, but is rarely used today because it has a low bandwidth of around 50 megahertz per kilometer. Now, these days, it has been replaced by graded index multimode with a bandwidth of up to 2 gigahertz per kilometer. So thank you guys. This is it. If you enjoyed the video, please like it and aiming for 200 likes. If we achieve 200 likes, the second part will be coming soon.